A whistle of frequency 540 Hz rotates in a circle of radius 2 meter at an angular speed of 15 rad per second. What is the lowest and highest frequency heard by the listener or long distance away at rest with respect to center of the circle? Can the apparent frequency be ever equal to the actual frequency? So the whistle, okay, whistle is the source, okay, it is the source of sound. So this is to be noted, okay. So what we find in this case, okay, is that the whistle is moving in a circular path of radius, okay, r equals 2 meter. So we have a whistle. So I'm taking whistle at this position, okay, or point. So this is a whistle, okay. So we have a whistle which is the source of sound, okay, and it is producing sound of frequency, okay, f equals 540 Hz. The whistle is the source, okay. So as I said earlier, it is the source of sound emitting frequency, okay, or emitting sound of frequency 540 Hz and is rotating in a circle of radius 2 meter at an angular speed of 15 radian per second. So we have angular speed, okay, of source, and let us denote the angular speed by the symbol omega. So this is 15 rad per second or radian per second. Clear? So we have this. Therefore, we can write, okay, we can write the linear, okay, the linear speed of the source, okay, is v equals r times omega. So what is this? So this expression gives, okay, this v, okay. So this represent, okay, this represent speed of source. So we can write in this way, okay, speed of source vs equals r times omega, okay, and we know r is 2 and omega is 15. Therefore, the linear speed, or simply we can write, okay, the speed of source equals 30 meter per second. So we have this. Now, what we know is that, okay, in case of circular motion, the direction of velocity at the circular path is given by drawing the tangent, okay. So let's take 4 different points on this circular path. So this is A, and I'm taking next point B, okay, point C, and point D. So I can take other points also. Now the direction of velocity at point A, okay, is along the direction of tangent drawn at point A. So we have this here. So this gives the direction of velocity of the source, okay. So at point B, the direction of velocity of the source is along the direction of this tangent, okay, and the direction of velocity of the source at point C is given by drawing the tangent at point C. In same way, the direction of velocity of the source at point D is given by drawing the tangent at point D. So we can also draw tangent, okay, at this point, clear? And the direction of tangent at this point gives the direction of the source at this point. I can also draw tangent at this point, and the direction of tangent at this point gives the direction of the source, which is the whistle, okay, at this point. In same way, I can draw tangent at this point, and the direction of tangent at this point gives the direction of the whistle, or the direction of the velocity of the whistle, okay, at this point. In same way, I can draw tangent at this point, okay, and it gives the direction of the velocity of the whistle or the source at this point, okay. And for simplicity, I'm taking only 4 points, that is A, B, C, and D, okay, for simplicity. So we need to note that, okay. And what we find, we are asked to find this, okay. What is the lowest and highest frequency heard by the listener a long distance away at rest with respect to the center of the circle? So let's say, okay, the listener, okay, let's say the listener is, okay, we have listener. So this is observer, okay. So this is observer O, and it is at rest, okay. It is at rest, and the speed, okay, of the observer, that is V naught, equals 0. So we have this. So we are asked to find what is the lowest and highest frequency heard by the listener or long distance away at rest with respect to the center of the circle. So I'm writing over here. We have speed of observer V naught equals 0. So we have this. Okay. So we have this. So we have this. Now, we are asked to find the lowest, that is minimum, and the highest frequency. Okay. So let's understand in this way. Okay. Case 1. Okay. For lowest frequency, since the observer, okay, since the observer is at rest, okay, therefore we write in this way, okay, frequency heard by observer is lowest or minimum when the source, okay, when the source moves away from the observer. And in this case, okay, the observer is at rest. So we see, okay, as I said earlier, this is the direction of the source. So at point B, okay. So what do you find? I'm writing over here. At point B, okay. So we find this at point B. What do you find? At point B, on the circular path, okay, point B on the circular path, what do you find? At this point, the source is directed away. So I'm writing in this way. the source is moving away from the observer. So at point B, okay, we get the lowest or the minimum frequency. Clear? So lowest frequency is obtained, okay, at point B. So we have this. Okay. Now what we find is that, okay, so let us discuss this. Okay. We use this concept and generalize it for the different case in Doppler effect. Source moving towards observer and observer moving away from the source. Okay. And the frequency of sound emitted by the source is F, and the apparent frequency heard by the observer, okay, is F dash. And we know sound is directed from source to observer. So this is the direction of sound, and V is the speed of sound, okay, and sound always directs from source to observer. So we need to note that, okay. So we have this, and the speed of source is Vs, and the speed of observer is V naught, and the direction, okay, from source to observer is taken as positive direction. So I'm writing over here direction from source to observer is taken as positive, or let me write in this way, is taken as positive direction. So we use this concept, okay. And as I said earlier, okay, sound is always directed from source to observer, whether the source is moving towards observer or is moving away from the observer. So let me write, okay. Sound directed from source to observer. Okay, so we have this. Okay, we have this. Now for this condition, okay, we have F dash equals F bracket V minus V naught divided by V minus Vs. Okay, so we have this expression, okay, and in this expression, okay, we have neglected the speed of the medium. So we are taking medium, okay, we are taking medium at rest. We are taking medium at rest. So this is to be noted, okay. So we have this, or let me write over here, okay, medium at rest. Clear? Now what we do, as I said earlier, we are going to generalize this expression for different cases occurring in Doppler effect. Now for case 1, okay, this is point B, okay, and velocity of source is directed along this direction, okay. we have observer at rest. Clear? So what we find, we have a source, okay? This is whistle. This is whistle, which is the source of sound, okay? So we find at point B, the source is moving away from the stationary observer or listener. And as I said earlier, okay, for this condition, source moving towards observer and observer moving away from the source, okay, provided the medium is at rest, okay, provided the medium, okay, is at rest, okay, we have this apparent frequency heard by the observer, okay, this F equals F V minus V naught by V minus Vs. So we have this expression here where V is the speed of sound. So this is to be noted, okay. So we have this expression. So we are going to generalize this expression for this case. And we use this fact or convention, okay, sign convention. Direction from source to observer is taken as the positive direction. So what we find, source to observer, direction from source to observer. So we have source over here, direction from source to observer. So this direction. So let me, okay, draw in this way. This direction is taken as positive direction. Okay, so we have source moving away from the observer. Therefore, what we do is that, okay, the apparent frequency, let's say the apparent frequency heard by the observer is F dash, okay. So we find this F dash equals F. This is the frequency emitted by the source or the whistle, okay. And we have V minus, and what is V naught? V naught is 0, okay, divided by V minus, and we have source moving away. So what we do from this concept, okay, the direction from source to observer is taken as positive since the source is moving away, so that we have minus Vs, okay. We are using sign convention, okay. We are using sign convention. Clear? This direction is taken as negative direction, okay. This direction is taken as negative direction, okay. This direction is taken as negative direction. So we have this. Clear? This is to be noted. Therefore, F dash equals F times V divided by V plus Vs. So we have this. Now let us put the value, okay. And we know F, that is frequency of sound emitted by the source, is 540 Hertz, okay. So 540 Hertz. We know F is, so I'm writing over here, okay. F is 540 Hertz, okay. And what is Vs? Vs is 30 meter per second, okay. Vs is 30 meter per second. So we have this. And the speed of sound, okay. The speed of sound is, so what what is the speed of sound? Let's see what is the speed of sound. Okay. So the speed of sound, let us take this, okay? The speed of sound V equals 330 meter per second. So we are taking this, okay? The speed of sound is 330 meter per second. Okay. So we have this. And as I said earlier, sound always direct, or we always take sound, okay, directed from source to observer. So this is 330 meter per second. So we have this. Now let's put the value, okay? So we get f dash equals 540 times V, and V is 330 divided by 330 plus Vs is 30, okay? So let us find this. So this is 495, okay? So we get f dash equals 495 Hertz. So we have this, okay? So we are asked to find what is the lowest, okay, and highest frequency heard by the listener or long distance away at rest with respect to the center of the circle. So the lowest frequency, okay? So this is the lowest frequency. So this is the lowest frequency. Clear? So we have this. Now next, we are asked to find the highest frequency, okay? So let's see. Case 2, okay? Highest frequency. So let us come to the question, okay? Once again. So what do you find, okay? At point D, we find source, okay, is moving, or the velocity of source is along the direction of tangent, okay? So it is along this direction. So this is the velocity of source, okay, or the direction of velocity of source. So we find at point D, okay, the source is moving towards the stationary observer, due to which the frequency heard by the observer, okay, appears to increase, or the observer appears to hear more, okay? So what do you find? At point D, okay, we find this. So this is at point D, okay? So I'm drawing over here. Observer, okay, it is at rest. This is 0. So at point D, the direction of velocity of the source is along this direction, okay? So what do you find, okay? At point D, the direction of velocity of the source or whistle, okay, is directed towards the observer. Okay, so the frequency, okay, heard by observer, okay, at rest appears to increase, okay. We know the source is emitting sound of frequency 540 hertz, okay. So it is emitting sound of frequency 540 hertz, but the observer appears to hear more. So I'm writing. So the frequency heard by the observer at rest appears to increase. So we have this condition, okay. We have this condition at point D. We have this condition. Source moving towards observer. So we know observer is at rest. So we have this condition, okay. So what we know is that, okay, the direction. So let me draw in this way, okay. So we have source. This is source, okay. This is whistle, which is acting like the source. And as I said earlier, direction from source to observer, okay, is taken as positive direction. And we know sound, we always take sound directed from source to observer. So we take sound, okay. We take sound directed from source to observer. So we have this. Clear? So in this case, the apparent frequency, okay, heard by the observer. So let the apparent frequency be f dash, okay. So f dash equals f, and we have v minus v naught, and we know v naught is 0, okay, divided by v minus vs. So we have this. So what you find, source is directed or is moving towards the observer. Okay, so we have this. So we can write f dash equals f times v divided by v minus vs. So I'm writing in this way. Now let us put the value, and we know f is, okay, the frequency of sound emitted by the source or whistle is 540 hertz, okay, and the speed of sound is 330 meter per second, okay, and v naught, okay, sorry, v naught is 0. So I have written over here, and we know velocity of source. The velocity of source is 30 meter per second, okay. It is 30 meter per second. So we are going to put these value along with this, okay. So what we get is that f is 540 and v is 330, okay, divided by 330 minus 30. Now let's find the value of f dash, okay. So the value of f dash, that is apparent frequency, okay, is 540 times 330, okay, divided by 300. So we get 594. We get 594 hertz. Okay. 594 hertz. Okay. So what you find? This is the highest frequency. Now the minimum frequency is 495. Okay. This is the highest frequency. So I'm writing over here. Okay. Lowest frequency equals 495 hertz. 495 hertz, and highest frequency equals 594 hertz. Okay, so we have this result. Now let's come back to the question once again. Okay, so can the apparent frequency be ever equal to the actual frequency? So we are asked to find this. Okay, so for this, what we do, okay, case third. Okay, so I'm writing in this way. We have this. Okay, can the apparent frequency be ever equal to the real frequency or actual frequency? Equal to the actual frequency. So as I said earlier, okay, we have a source of sound, that is whistle. Okay, this is whistle, which is the source. Okay, and we have a listener, O, far away. Okay, so as mentioned in the question, and it is at rest. Okay, so V naught equals 0. So we have this, and the apparent frequency heard by the listener or observer, okay, is F dash. Okay, this is the apparent frequency. Okay, so I have considered 4 different points. Okay, this is A, this is B, this is C. Okay, and this is D. So the direction of velocity at point A is this. Okay, the direction of velocity at point B is this, that is along the tangent. So we have this. Okay, at point C, and at point D we have this. Clear? We have this. This is for source. Okay, that is whistle. So I'm indicating in this way. And at point B, what do you find? Okay, we find lowest frequency. And at point D, okay, we find highest frequency. Now consider, okay, consider points A and C. Okay, so what we find? at A, we find this, okay? At A, we find this. We have observer, okay, at rest. So we find the source, okay, is making angle 90 degree, okay, with this line, okay. That is the direction of velocity of the source is making angle 90 degree, okay, with this line. So we have this. In same way, okay, this angle is 90 degree. So we find this. Okay. So we find this. Now, let us understand this problem in this way, okay. Let's say we have a source. So this is a concept. So this is a concept, okay. And we have an observer. Let's say we have an observer. Here we have this. Now, let's assume that the observer is at rest. Okay. And let's say the source is moving with speed Vs. So I'm writing in magnitude, okay, making angle theta, okay, with this line joining source and observer. So what do you find? We can resolve this Vs along this direction so that in this direction we have Vs cos theta. So we have this, okay. Now, if we have this condition, okay, then we can write in this way, okay, f dash this equals v minus v naught by v minus Vs cos theta, and we have f. We are assuming medium at rest. Clear? We have this. Clear? We are taking this condition, and for so observer at rest, we have V naught equals 0. So we have this. Therefore, we can write f dash equals V divided by V minus Vs cos theta, and we have f. Now we are going to use this concept and generalized in this problem, okay. We are going to use this concept or formula in this problem, okay, and we generalize it with reference to this problem. So what do you find? We find angle between the direction of velocity of the source and line joining the observer with the source, okay, is 90 degree. Therefore, theta equals 90 degree. Clear? Now, at point, okay, A, what do you find? At point A, we find source is directed along this direction, and at point C, the source is directed along this direction. So for point A, okay, so as I said earlier, we are going to use this concept, okay, this concept. So at point A, okay, so we find this at point A. At point A, okay, let us find it. For point A, f dash, clear? With reference to point A, we are working with reference to point A. We have V divided by V minus Vs cos theta, and cos theta is cos 90 degree, okay. So we have this and we have f. Now we know cos 90 is 0. Okay. Cos 90 degree is 0. Therefore, what we get? F dash equals V divided by V. Okay. F. So this cancels out. Therefore, F dash equals F. So what we are getting? Apparent frequency equal to the actual frequency or the real frequency. Okay. So we find at point A and C. Okay. So I'm writing conclusion over here. At point A and C, apparent frequency equals, okay, actual frequency. So we have this.